Hi everyone, I wanted to add a little more clarification about the U-shaped tube example that I did in class. The first thing I'd like to review is the concept of pressure, the definition of pressure, and the unit. So pressure, again, is force over area. And the unit for that is Newton per meter squared, which is equal to a Pascal. Now let's break that down just a little bit more. A Newton is a kilogram meter per second squared. Again, it's because it's mass, force is equal to mass times acceleration, so kilogram is the unit for mass, meter per second squared is the unit for acceleration. Meter squared is already in its most basic form. And now let's simplify this. Kilogram, meter per second squared, and then we would have meter squared on the bottom. If I were to simplify this, 1 meter would cancel out, and I wind up with a kilogram over meter second squared, which is kind of a weird unit. And you can see why maybe we'd like to call it something simpler like a Pascal. We'll come back to that in just a moment. But now let's look at the U-shaped tube. So I took a better picture of it. I did a better job of setting it up. I took out some of the water because there was too much water in the one that I had in class. And what I'm going to do is I want to think about why is it that the oil, so this is oil, which, by the way, has a density of 911 kilograms per meter cubed. Why is the oil column taller than the water? Oh, let me redo that. So the water I had dyed blue, and the density of water is 1,000 kilograms per meter cubed. So in class I had talked about the idea that the difference in heights was due to this density. And now I would just like to explore that in a little bit more depth. So another thing that we talked about in class is that any place on here is at the same pressure. And I'm going to pick a convenient place, a horizontal line. I'm going to call that my, oh, that's not a great color. Oh, go back. I lost it. Oh my goodness. Third time's the charm, I hope. So the idea is if you draw a horizontal line anywhere on this diagram, you're going to find constant pressure. So now let's try to figure out why the heck that might be. What I'm going to do is I'm going to look at the height of the water column. And I don't have this shown, you're going to have to take my word for it, that the height of this water column is 11.6 centimeters or 0.116 meters. Again, that's for the water. Okay, now I'm going to do the same thing for the oil. The oil goes up to the second line. And the oil has a height, and again, I'm not, you're going to have to take my word for it, of 12.5 centimeters, which is about exactly 0.125 meters. So this difference here, this little difference is just 0.9 centimeters. It's just like a centimeter difference in the oil and the water, which is not a very big difference. Okay, so now what I'm going to do is I'm going to find the mass of this column of water. And again, I'm just finding the mass of the column between these two purple lines. I'm sorry, I take it back. I'm gonna find, actually, I'm not gonna find the mass. I'm gonna do this right. I'm gonna find the pressure of the column of water at the constant pressure line. So again, that's this line. I drew it in green, now I'm drawing it in purple. I'm gonna find the pressure right there. So to do that, I'm gonna use something called gauge pressure. Gauge pressure is pressure due to depth, and it's equal to rho, density, G, 9.81, times H, the height of the column. So for water, that's gonna be 1,000 kilograms per meter cubed times 9.81 meters per second squared times a height of 0.116 meters. Okay, and then I'm going to get out my trusty calculator, which I can't find. I'm reaching for my cell phone in my pocket. Let's see. Okay, 1,000 times 9.81 times 0.116. Maybe you can beat me to it. So I got 1138 pascals. And remember that a pascal is a kilogram on the top, second squared on the bottom, and then meters on the bottom. And we've got meters cubed here and then 2 meters, so this would just turn out to be meters on the bottom. So again, the units work, is what I'm trying to say. Okay, now I'm gonna do the same thing for the oil. I'm gonna do the pressure of the column of oil. And again, I'm gonna use gauge pressure, which is rho GH. So notice the rho is smaller, it's 911, but the H is bigger, it's 0.125. So let's see if this actually works. So it's 911 times 9.81 times 12.5, oops, no, 0.125, pardon me. Okay, I've got my trusty calculator, 911 times 9.81 times 0.125, and I get 1117 pascals. So this was an experiment that I did with materials in the classroom. These are supposed to be the same. The pressure of the column of water at this line, this line that I just made purple, should be the same as the pressure of the column of oil. And when the density goes down, the height has to go up in order to keep that gauge pressure constant. And that's the big idea behind the U-shaped tube with water and oil.